Hi everyone. I'm Dipanshu, and here is my presentation for Capstone project. So, what I'm trying to do is predict campaigns, open rates with subject lines. I work as a senior software engineer in analytics and at Intuit Mailchimp. So in Mailchimp, we have this concept of email marketing campaigns where we allow users to send campaigns, and you can see we are specifying to, from, subject line, and the content of the email campaign. Uh, so as you can see, like the subject line is what we will be focusing on. If you have got an email, the subject line, if you have seen a subject line on it, that's what exactly we are referring to. And based on this we can predict we are trying to see if we can predict open rate correctly or not, and this is the open rate for this campaign, this email that was sent to maybe hundreds of users or thousands of users, and this campaign has this open rate. So this would be somewhat like kind of a data set where we have like individual campaigns at their open rates, and we are trying to see for a new campaign with its new subject line, would it perform better or worse. Let's talk about the data. So we would have rows of individual campaign data. We have taken the data from 10th February 2020. Why? Because to current, because that's what gave us enough data that there is no logic behind that date. We also seeing if the email sent is more than 1,000, so it's not does not include test campaigns and things like that. And the data is for a specific user and its corresponding audience, so we are not there is no difference of how industry would play into a role or how different audiences would behave. So with that said, so the problem statement is in MailChimp, we help our customers send email marketing campaigns to users. We send close to a billion emails every day, and most of our customers are small and medium enterprises. So these small medium enterprises often care about their how their email campaigns are performing, and open rate is one of the important metrics for measuring success of campaign. Rather than figuring out the campaign uh, after it's sent, or rather than predicting open rate after it is sent, the goal is to predict it before it is sent based on the subject line. And uh, and how the way we have modeled this problem is it's a supervised learning classification problem. So we are trying to predict whether a campaign will do better than its typical median performance or worse than its median performance based on the subject line. And we've used bucketing to convert this regression problem of predicting an open rate, which is a number, from a regression problem to a binary classification problem. We used a lot of different kinds of hardware, and, uh, and so I used two GPUs along with four virtual CPUs in my Google Cloud project. Uh, Before we go into performance, let's go over the Jupyter Notebook. Um so right, okay. So this is the Jupyter Notebook. And So first we're installing our dependencies. We have a lot of different kinds of dependencies. We are trying to like there is a lot of feature engineering done because all the data we have right now is just the subject line and the time it is sent on. So based on these two features, we will be creating more features. And the way we have done it is like first we have like removed anomalies. So if there are any outliers which are like outside the standard distribution, we remove it. We also then remove nulls. If we also use lang detect to detect the language of the subject line, and if it's anything other than English, we remove that. um, we also add features like subject length, which is just length of the subject line, words the subject has. We also see if the subject line has personalized messages, so if it has like uh, a contact's name in it, so it's like hey Dipanshu, check out this email, and this Dipanshu is very personalized. So we are checking, trying to see if it has these merge tags or more specifically personalized emails. So does this have emojis? What's the sentiment of this analysis? And then finally we create a clean subject line that has no emojis, no other encodings, no stop words, and just normal pure subject lines, pure text. For data exploration, these are the different features we have now extracted. So we have email sent, subject length, subject words count, subject sentiment score, send year, week of the year. For categorical features, we have emoji. Does it have emoji? Does it have more tags? Does it end with a question? Is it an holiday? What's the send time of the day? What's the send month, day, and season? Right. So I think here we are doing some categorical features like uh, based on the send date, like what's the year it's in, what's the month it is in, what weekday it is, what week of the year it is, and things like that. And does it fall on a US holiday? uh, and then we are doing a lot of data exploration, and trying to plot all this EDA. We didn't get too much through the EDA, and if you see, like, none of these features are very strongly correlated with each other. So it was kind of hard to like use one feature and say, yes, this is what we had. I also created a word cloud, and you can see like what a lot for this user, for this set of data. uh, they talk about a lot of craft, fun, weekend, and things like that. So now we'll talk about modeling and the machine learning part of it. Uh, so f- so I've divided the machine learning problem into three different kinds of problem statements. So we had all these features, uh, with different kinds of. So in the first part, we'll only explore numerical and categorical features. This is what evaluation based on non-text features is. And then in the second part, we will evaluate based on only text and nothing else. So no non-text features. And then the third part, will combine all of them and see what's the performance. So let's start with evaluation based on non-text features. So we have used standard scalar and one-hot encoding, depending on what kind of feature it is. And then we are combining, then we are trying to use different kinds of classification algorithms to predict the performance. And it's and finally we are doing grid search to see if we can like improve the performance overall with hyper tuning, with parameter hyper tuning. um, Fine. So as you can see, like, the best I could get was like 78% accuracy. Let's talk about with text. So what we did with text was, like, we used the clean subject line we had created here, and we will be using that as our feature. And um, and then we use the classical machine learning problems, and in here, I think roughly most of the tree models performed similar. They're about 63-64% in performance. We also tried using with transformers, which are neural networks, and the state of the art. Unfortunately, we didn't get that level of performance here, and it was pretty much close to a dummy variable performance here. Um let's talk about uh, uh, so yes. So now finally, let's talk about combining text and non-text features. So there are different ways we could approach this. Like, how can we combine these uh, text features to non-text features? And one way is like just combining, just putting them all the numerical feature as a string. So if you see, this is all my numerical features, but like I'm converting them all into a string. So subject emoji is false, subject merge tags is false, and things like that. So the test data becomes a list of strings with numerical and text data combined. uh, Once we do that, we can like train this similarly as we did with the transformers and see how our performance improves. and unfortunately it didn't give that level of performance again with like just with performing as similar to the dummy variable. Then finally we can move on to the classical ML part of it. Can we use similar can we apply uh, classical ML approaches with uh, such as such as with different types of embeddings like TF-IDF and bag of words, and see uh, see if we see what's the performance, and it seems like it performed better the than the previous one. So finally, we talk about like there are other ways we can also combine these text and numerical features, and one of them is like concatenating them concatenate their text features with the numerical features like this. And there are two ways there are two ways I've tried it, one with TF-IDF and the other with BERT tokenization. So let's with having said that, let's talk about how we what was the performance we noticed. um, all right. So for performance, it seemed like the best performance we got was with no text features and XGBoost. Uh, when we did only text features, it seemed like the best performance we got was with multinomial knife base, and although I think XGBoost also still did very well. Um, and this is not with grid search, so there is potential to improve here with hyperparameter tuning. uh, when we combined with all features, I think the best we got was 64%, which was not very different from the only text features. um, However, it seemed like adding the text features did not improve the model performance, and even if we just used no text features, we would have gotten a better performance with just the model itself. Um, so what did we learn? So turning a regression problem into a classification problem, especially for natural language processing problems, creates better results. And thanks to Prashant for like helping me with this key insight. Uh, and multi-class classification is harder than binary classification. Again, I was trying it with four class like instead of binary classification, a four class classification problem, and the performance was not very good. Um Finally, tree based models like XGBoost sometimes perform much better than state of the art transformers and other neural networks. So take what you will. I've the As we saw it uh, in our for this particular data, XGBoost and naive base were doing much better as compared to other models. Um, so GPUs really speed up neural network from 1 hour to 5 minutes. So this is something I wasted a lot of time on. I did not start with using a GPU, and I had to wait like hours and hours for my Jupyter notebook to run. But once I added GPUs uh, to my compute environment, it was blazingly fast. um, so one of the most important features we found was like email sent was the most important feature out of all the numerical features. And the idea the, so what we are so what it so what we can like infer is like from this, like if you see like the more emails you send, the the more open rate it is, the more open rate you have, the more people open it, and which is very counterintuitive because the formula of open rate is opens by email sent. But in this case, what we found was as the more emails the user sent, the better they performed in terms of open rate. Conclusion: it was a harder problem to solve. There was no strong correlating feature that could have predicted opens, and we could have added more features like what browser, what email client the people contacts were using, frequency of campaigns to evaluate it further. And that is all I have. Thank you for your time. Appreciate it. And thank you, Prashant, and everyone in the team. Appreciate your hard work.